check for the YouTube link.
YouTube link doesn't work.
It just says we are live.
Oh.
I can see a mixer and sources and a mini feed.
It says we are live, but
Now I can see your browser, so I'm seeing something.
okay. So
Yeah, I can see that too.
I can show you in camera. Wait, does this work? Yeah.
perfect.
This is what I see on YouTube Live.
Very well. Okay, it's perfect.
Well, we're on.
Okay, we are okay. Okay, it's yeah, it's perfect.
Let me mute.
Now I hear myself.
It says we are live, but I will just okay. So
Yeah, I can see that too.
I'll show you in camera.
okay. So
Yeah,
perfect.
I can see that too.
I'll
Very
show
well.
you in camera.
Perfect.
This is what I see on YouTube Live.
Very well. Okay, it's perfect.
Okay, and the sound is good too. It has a little bit of delay for me, but it's good. Yeah, I could hear you. Let me check it again.
Very well. Okay, it's perfect.
Okay. Yeah, I can hear that. I can hear myself too. Yeah, it's working. Yeah, it's working.
Yeah, on my shirt. Yeah, a friend of mine is an illustrator, an artist, and he drew this for me one day. It's like I'd like something playful with colors and sticky notes that I can use in business, but that also doesn't look too business-like. And he came up with a logo, and I really like it. Both. I'm a lead developer in a company in Germany, and I've been working in the same company for 14 years, and we build healthcare systems for Germany. And I'm also a freelancer as a consultant and trainer for domain-driven design, event storming, and all these things. Since I've been doing all the DDD stuff for like about 10 years now, or 11 years, I started to teach and consult in other companies at some point. So I have an 80-20 job. 80% of my time I'm building software, and 20% of my time I'm teaching domain-driven design.
I think coffee was really effective.
Thank you. Hello, Aaron.
Hello.
I can see a beautiful gray square.
That's me.
Okay, so in we go live at 18, right? At 6. Okay, perfect. Yeah, so DDD has had a lot of change in the last year due to the pandemic. The virtual DDD community grew a lot, and that's pretty amazing. So, and also DDD Europe changed their program to a lot of virtual trainings, which is a trade-off, but it's oftentimes really good. But I can't wait to do event storming in physical space again at some point. Yeah. Yeah. Also has downsides because you don't have the communicative component, the emotional component of being in a physical space, and you don't see who is engaged, who is disengaged. You just see mouse cursors and sticky notes. So it has a lot of upsides on the complexity of the models. You can just copy a large part of it, move it around, change stuff, store everything easily. But it has downsides on the communication part. And yeah, I think after the pandemic, or when everybody's vaccinated, or whatever makes it possible to model again, a good mix of both methods would be fine. I don't think that we will go back to full physical, but I don't want to stay with full virtual also.
Yeah, I miss the non-virtual events too.
Yeah. Yeah, well, I think what the virtual events have the problem of the filter bubble. Every event I go to is like, it's a low commitment, right? There's an event, I can just click on a button, listen to the stream. If I'm not fully engaged, I just don't care. And if I really like the topic, I'm there. But that gives me a filter bubble. I'm speaking to an echo chamber most of the time. And in a physical conference, when you meet people in the floor and then the between the rooms and you have discussions, you can't just say nah topic nah. You're there, and I've learned so many things in second order ignorance, things I didn't know that I didn't know just from having physical contact to communities. So there's a lot of inspiration that I'm missing now. I can't wait to go back to some conference. Yeah.
They will come, I know.
Yeah, again, same thing, right? It's a virtual event, so the commitment rate is pretty low usually. It's in the afternoon and you're thinking like, oh, I'm so tired. You click on a button and you're at some point like, nah, let's just get a pizza and
I think many people have set some reminders or something. They're probably gonna come after 8:30.
8:30.
You, you know.
Oh, sorry. Yeah.
But I think it was really great that we got the chance to see you. But if it was physical, we couldn't really participate in this event.
Yeah. Me. Been speaking the whole day on microphone. last year I started doing singing lessons just to improve my breath and my voice. Yeah, I realized when I've been talking for days and days on end, at some point I get a sore throat, and learning to sing actually made it better to speak in front of the camera. So yeah. Yeah. I can highly recommend take just like 2 or 3 hours just to get the first breathing exercises. Realizing how to breathe properly and how to pace your speaking helps you so much with your voice when you get sore in the end of the day. You're welcome.
Okay, right now 5 people are watching you through YouTube.
Yeah, so if anybody's on YouTube right now, if you see the stream properly, can you give us a comment, a thumbs up or an okay in the stream so that our moderators can see that it's working properly? And then we start in a few moments.
Yeah. So it's happy day if you tell us if everything is okay on YouTube. We can go online.
Yeah, everything is working perfectly.
Okay, it's perfect. So let's start, or we will wait more.
Yeah, I don't mind either or.
Okay.
Both fine.
Okay, let's do that. So, okay, so hello everyone. I welcome you to this new webinar that DDD Iran organized with Shodo. For this event, we have Marco Heimassoff. I hope the pronunciation is good.
Good.
We are really happy to have in Marco. He is one of the person who is really active in DDD community. He is from Germany. He organized Kandinsky, and he is one of the members of Virtual DDD. So for today's session, we choose we choose a subject, an introduction to domain-driven design, because we have many people from DDD community in Iran that are interested about this subject and wants to know more about that. So I will let Marco to introduce himself and go on. Thank you, Marco.
Hi. Thank you very much for having me. So yeah, I was pretty excited when you asked me to give an introductory session. The last introduction session to DDD I gave is a long while ago. Yeah, let me share my screen. I've prepared some slides. Or before I do that, throughout the whole session, this will take an hour, up to 2 hours tops, but let's plan around an hour. Asking questions is always okay. So if you're on the whereby.com, just feel free to ask questions at any time. The moderators will open up your mic or however that works. But ask questions in written or spoken form. I'm super fine with being interrupted. If it gets too cumbersome at some point, we'll drop the mics and pause it, but I'm super fine with questions in between. If you're on YouTube, please write your questions in the chat, and the moderator will then ask those questions in the given time. While you're not asking questions, please mute your mic so that we only hear my beautiful voice throughout the session. So yeah, so much for preparations. Let me share my screen. Yeah, so I've been introduced already. My name is Marco Heimassoff, and I founded the German DDD community like 10 years ago or so, in 2011, 2012. And we do a DDD barbecue once a year. Well, we did until the pandemic hit the whole world, right? So we're looking forward to next year when everybody's vaccinated. But what we do is we meet once a year, all the members from around the country and also other countries, talking about all the hot stuff in domain-driven design. And we always encourage and invite other people to do DDD barbecues around the world at the same time so that the community spreads and grows. And once I think 2022 starts, we're going to plan the next Kandinsky again. It's our domain-driven design conference that we have once per year in Berlin. It's a very small community-driven conference with 200 to 300 people, and it's very hands-on approach. So it's more about the collaboration and learning together than about long talks and sitting on chairs and listening, like you will be doing now. And yeah, we also founded the virtual DDD community with a few people like Kenny Bass, Christina, Sophie Herendi in 2019. And right now in pandemic times, if you want to learn more about DDD, that's actually the place to go. So if you want to see a lot of sessions from the past, we have everything on the website. There is also a section called how to start with DDD or the learning journey, where there's a curated article about how to start with domain-driven design. And as I said, every 2 or 3 weeks, there's another session. If you have a specific topic you want to discuss or talk about, go to virtualddd.com, propose your topic. Everybody's welcome there. It's a worldwide community, and if you have questions, answers, or just want to hang around with DDD lovers, that's where to go. Okay, now talking about the topic, domain-driven design. Let me see if I can make this full screen here.
Excuse me, Mr.
Yes.
Namdar, some people say that YouTube channel, the voice is weak, and can you turn it up a little bit?
Yes, sure. Marco,
Okay, you do that?
yeah, I will try to do that.
Okay. So hello YouTube. I hope my voice is not too weak. Yeah. So domain-driven design. What is domain-driven design?
I can make it higher. So if you can do it,
Okay.
thanks.
Thank you.
I can try to increase the gain. How is it about now? Well, let me know if it's better or worse. I just increased the gain a little bit. So yeah, domain-driven design. What is domain-driven design?
It's better, I guess.
Thank you. Again, what is domain-driven design? Domain-driven design is the title of a book that Eric Evans wrote in 2004. And it was a book about tackling the complexity in the heart of software. Well, it still is a book about that. And the domain-driven design book started a movement a few years later after it'd been published. It started a movement, a community worldwide of people who focus on the business side, on separating their problems into smaller business problems and proposing solutions that are aligned with the business or the domain knowledge and solved in a specific language, in the ubiquitous language. So code that is written in the terms of the business itself. And these and a lot more patterns are the basis of domain-driven design. That's what the whole book entails. Many people start reading the book, and after like 7 or 8 chapters, they say, hey, I got it. Now I got the idea. I've read everything about entities, aggregates, repositories. Now I know how to build domain-driven software. Awesome. And that's a big problem in the community, or it was for a long time, because the true value of the DDD book is in the later third of the book, in the last third of the book. That's where the strategical patterns come in, the actual analysis and the communication and modeling parts, the subtle design. The first part of the book about tactical implementation patterns, that is, as Eric Evans put it once, written in the wrong order. He would have written it the other way around, or basically made 2 different books for it if he would rewrite it now. Well, today, domain-driven design is not just a book, it's a worldwide community. There is conferences around the world, the biggest one being DDD Europe in Amsterdam once a year. Then there's DDD Denver, the Explore DDD conference in Denver, Kandinsky in Berlin. And there's communities popping up all over the world, like DDD Iran, DDD Germany. I've seen DDD Thailand, DDD New York. Like every bigger city has now a local community. The last big thing was virtualddd.com as a community-driven website where everybody's talking together. Well, domain-driven design, I already said it, has 2 different things. The tactical part, I've shown it here on the right side, and the strategical part on the left side. And DDD is not a closed set. It's not you don't have a boundary where you can say this is DDD, this is not DDD. Domain-driven design is like a gravity well. It is an open set of ideas, and some ideas are really close to the core, like bounded context. Yeah, that is a word by Eric Evans from the original book. Aggregates, value types, entities, repositories, and the ubiquitous language itself. Those are implementation patterns from the tactical side. And there are other things that came over time that are really close to DDD or that are used in context of domain-driven design all the time, like event storming as the modeling method to, on the one hand, understand the strategical landmarks and the strategical topology of your company and of your problem spaces, as well as designing solutions, and CQRS and event sourcing as architecture patterns or actor model. Those things themselves aren't domain-driven design. Excuse me, can you please mute your microphone? I'm hearing your telephone in the background. Yeah, so these patterns aren't themselves domain-driven design, but they are used in context of DDD all the time. And there are newer modeling methods popping up, like domain storytelling, user story mapping, which wasn't in the DDD context in of itself from the get-go. it was more of an agile methodology, but it's so compatible with the mindset of DDD. And then you have complexity theory like Kinevin or Wadley mapping for strategical modeling. And this is by no means a finite list. It's just some stickies that I came up with in 10 minutes, drop them there. You can do this all day. There are so many different things that you can try when you do DDD. The core value is if you want to design your system driven by the domain instead of driven by any other need first. So instead of optimizing for performance and thinking about architecture first or what tool to use and then try to shoehorn your domain in, what you do when you do DDD is you focus on understanding the problem from a business point of view or from a domain point of view. And then you try to come up with solution models, with proposals that could actually solve the problems or optimize the behaviors you want to optimize. And then you implement them with methods or with technologies that actually reflect your understanding better. So if you use an entity, for example, like something, a noun with a lot of behavior that is protecting business constraints, that is a very valid way of doing DDD. If you don't do object-oriented programming, but you do functional programming and you're using event streams to project state from there, that is also a valid way of being more domain-driven in your implementation details. If you use event storming for modeling or domain storytelling or none of these methods, you can still do domain-driven design with other things, with other methods. All of these things are in the landscape, in the gravity well of DDD, and I try to put them here kind of by my own opinion of where I think they belong. But of course, this is highly opinionated. So there's a good talk on the virtual DDD website called What Makes You a Domain-Driven Designer from a month or two ago, where the whole community, like 20 people from the community, are discussing all these topics for over an hour. So if you want to go deeper into that topic later, I can relay that link to you, and that's a very valuable talk. But yeah, so to understand what DDD is, in the pure sense of things, the DDD book was about how to implement more linguistically in the terminology of the domain and how to model and strategize on the strategical part, how to build architecture and separate your systems in a domain-driven sense. And any pattern that makes you more in that direction is a good pattern fitting into the gravity well of DDD. Okay, so from one of my favorite Italians, Alberto Brandolini, the inventor of event storming, comes a quote: "Software becomes what developers understood, not what business people meant." And when I first heard this quote, I was like, yeah, sure, I know what he means. And I was pretty sure to understand this quote because, yeah, you know, you get a description of what people want and you read like 200 pages and then you provide a solution. And then in the end, you realize, that's not exactly what they wanted. But then you iterate because you're agile, right? So you can always iterate. But yeah, I got the problem. So I knew I need iteration and modeling to get there. It took me a few years to really understand how much this is still a big problem in the whole industry, because it's not the developers, meaning the programmers, it's the whole developing company. So if we as a company with designers, testers, QA people, product owners, programmers, if we build something, what we understand is the closest thing to business problem that we actually understand is the best solution we can, determines the best solution we can deliver. So we need to understand the business side fundamentally at the same level or even deeper than the customers we're trying to help and we're trying to build software for. So there is no way around actually cooperating with your customers. And the less hoops you have, the less jumps you need to make between the customer or the domain experts and the programmers, the better. So the classical companies where you have like a product owner, not even a product owner, where you have a business analyst telling the architect what they need and the architect telling the programmers what to build, and the programmers code something, and then you realize I have a question, but you can't just ask the customer. You need to bring up all these questions in the next planning session, and then the architect will go to the business analyst in the next strategical meeting, and then they will tell you what they think the customer needs. Like, this takes ages, and this is why Agile exists, right? To do customer collaboration over comprehensive documentation and following a plan and all these things. So this is where DDD also shines. DDD is highly compatible with Agile. You can iterate a lot, And if you model upfront a lot, that's something where Agile people often have a problem with, to say, we don't want to have big design upfront. DDD never tells you to do big design upfront, but big discovery upfront is necessary. So you don't have to come up with a solution how you want to solve problems in the first go before you start sprinting or before you start building anything, but understanding the business problems is highly important. So big discovery upfront, super important. And we're going to talk about the event storming method a little bit later. But yeah, this is where Eric Evans' initial model exploration whirlpool comes in. So Eric Evans in 2016, I think, gave a talk about how Agile fits well together with domain-driven design. And the idea of model whirlpool exploration is you can start anywhere in this whirlpool. Let's start here with a scenario, right? What you do is you tell a story, very concrete and specific story. You walk through it, flesh it out, refocus on the hard parts, and specifically on the core domain, on the thing that provides actual distinctive value. And when you have a scenario that you, as a developing team or in collaboration with a customer, come up with, then you want to propose models that solve problems in the scenario. So if you want to be concrete here, right, you have a new shipping scenario, how you want to ship your wares from your Amazon warehouse. How do you get them to the customer? Yeah, we can do drone, we can do this, we can do that. There's also a mobile app involved now. Propose a model that would actually solve those problems. How would you do this with software and also organization or hardware? And then you walk through the scenarios, describe everything as events, what happened, and states. What can we do now? In what state are we in? You explore the language and you add rigor to the model. And you're allowed to make mistakes here and mark the mistakes as, hey, this doesn't work yet, but let's continue modeling here. So when you have a model that would actually solve the problem or most of the problem, you can do a code probe, quickly implement in the language that you just used, implement your code so that your code actually reflects your best understanding of the domain. This does not require frameworks, big UI, Kafka, any kind of storage in the backend or cloud. It's just about a domain model, implementing your behavior, your data in the language of the business and in the language of the domain that you just modeled. And you use the code probe to quickly get feedback, because coding is also thinking, and coding stuff needs more structure and it needs to be more refined than just talking. Language can be fuzzy and we don't even realize it until we try to implement, and then we realize, oh shit, yeah, this doesn't work. Or there's an if-else statement, but there should be a switch case, right? What are the other cases here that we missed? Cool. That code probe gives you quick feedback, and you now know, hey, there are other cases we forgot. There are things we need to iterate over. And this is how you challenge the next scenario. And then you tell a new story with all the new things that you've learned from modeling, from probing, and then you keep on cycling through this whirlpool. And you see there's this big cycle going through every step, but there's also smaller cycles inside of every step. While building a scenario and telling a story, you can iterate quickly over multiple aspects of a story, figuring out what you want, what you don't want, refining until you go on with the modeling. And all of this can be collected and documented in, well, whatever way your company or your team supports. So nowadays, tools like Miro, because we need remote collaboration due to pandemic, or many companies might even need it because of local distances. Tools like Miro or Notion or Mural boards or any kind of wikis, whatever floats your boat and fits your scenario in that moment is fine. Even writing unit tests as codes documentation is also fine. Telling stories in BDD style, writing something in Cucumber. It depends on the people you're working with and the shared tools they can actually use and understand. Find the most fitting tools. Well, anyway, that is a domain model exploration whirlpool. And yeah, even the way of how to document and implement stuff in here is something that you can go over with small controlled experiments, which will be a thing that we mention a lot during this workshop. Small controlled experiments is basically one of the underlying heuristics of domain-driven design. So there's a quote by Melvin Conway, a famous programmer, and I think he said in the 60s or 70s, and yeah, he's still alive today, and even gave a talk at Ddd Europe a few years prior. But yeah, he said organizations which design systems will produce designs which are copies of the communication structures of these organizations. Well, that's an abstract sentence, right? But what does it actually mean? What does it mean that if you design a system that you will reproduce the communication structure of your organization? Well, in the most trivial sense, if you have a strong hierarchy, if there's a boss and there's sub-bosses and then there's the soldiers working down there, if that's your hierarchy, you will not produce software that has a lot of components that different teams work on and they all trust each other in communication. And there's kind of like just a shared information understanding of all the models. That doesn't work, because if you have a strong hierarchy in your organization and your team messes up, your boss will have something to defend against that boss, and then there's pressure from above. So of course you will align your system alongside your organizational structures. But it's not even just these very placative and plain examples. It's very subtle things. If I work in a team and the collaborating team I work with, let's say shopping, cart management, and delivery are two things we build, and there are two teams working on both topics. If those teams actually share an office, if there's a big co-working going on and they are private friends and they share their lunch break and they talk about all the things, big group hugs, if that's a situation you find yourself in, the software will be in deep trust. If there needs to be a change in API, both teams will quickly share a model, make some whiteboard drawings, and there's no need for defensive programming. They work pairwise, hand in hand. There's a high bandwidth of communication, which is also costly, right? But there's a high trust, and this trust reflects in the system you build. If one team sits in India, the other team sits in North America, and there's a time gap in between, so they never really overlap in their waking hours, and there's also different company cultures for both teams of how they actually operate. Well, there won't be a deep trust between both parties, right? I'm not just sharing my code with you or give you access to my data structures or my database. There will be an anti-corruption layer. There will be an API that I clearly document. And if I'm upstream, or if we are upstream in our India team, then we make sure that we define exactly how this works. And when something changes, we dictate the change. And the America team is downstream. They just adapt, and they need to protect themselves from all these changes, but they can't really change anything on the other side. So the way your social structure is organized always reflects on the systems you build. And this is one of the major strategical tools we can use when building systems, because shaping the organization that is producing solution has an immediate measurable impact on the systems they're building. And this is called the Conway Maneuver. You can change your company structure. You can reteam people to a certain degree, right? Because people are humans and social beings. So you can't just reteam everybody all the time. People are not resources. But if you change your team structures and you change organizational structures, the system will follow without you having to dictate what to make of the system. And there's also something called the inverse Conway Maneuver. You can do this the other way around. If you say, hey, look, the system has been upstream, downstream message pump, but they all need to share one code base now. It needs to become one whole system. The teams will start to communicate in that way. These are, of course, heuristics. There is no guarantee. It's not like you can plan it and make it happen just by dictating it. But these are tools that are heuristically shaping how people behave and how systems grow. Depending on what forces push where, you need to keep a keen eye on it, but you can use this to your strategical advantage when building complex systems. And you also need to be aware of it even if you're not using it as a tool, but you need to understand that if you change your organizational structure, your code base will change over time. It will reflect that structure. So this is where a lot of friction comes in play. When you start your company, for example, fresh, you have a quick setup of people, you have teams working in a certain way, they build a certain architecture. And then you change how your company operates. But the software is already in place. So it's not easy to change a big legacy system, right? If it has been growing for 3 to 4 years or 5 years, at some point it will take months to actually adapt the system. So be aware that over time, your organizational structure might change quicker or at different paces than your software structure. And that's always where a lot of tension comes in, because now I'm responsible for something, but I'm not accountable for it. I haven't built it. I can't be made responsible for this, but I am. So this is where people start to become defensive or where teams get frustrated, and mitigating that by making it very transparent from the get-go, super important. And yeah, before I go on over Melvin Conway now, this is where bounded context come in. Bounded context is one of the two major patterns from domain-driven design, the other one being ubiquitous language, right? Bounded context is more on the strategical side, ubiquitous language more on the tactical side. So the bounded context is like a smaller part of the system that you're building, and the smaller part of the system has a mental model bounded inside. So you can clearly say what belongs into this model and what does not belong into this model. And what we want to do is we want to find those bounded contexts that actually structure our system aligned with the business needs. So our bounded context won't be database layer, business layer, UI layer. That would be the worst map ever because it's totally non-business driven. But having something like shopping, fulfillment, delivery, payment, yep, this is how I would build Amazon back in the 90s. Of course, this is a trivial example, right? In reality, a context map is more complex. There's probably 20 to 30 bounded context here or so, depending on size of the business and details of the models. But let's assume our domain would be online retailment, and we have certain subdomains. We have parts of the domain that are separated mental models. So we now have two different things. We have something called a problem space, or how I like to call it, a purpose space. And we have the solution space, or better, the proposal space. So the purpose space is where the business exists. The business does online retailment. And inside of the business, there's a part of shopping. There's business experts talking about how can we advertise more products to these people so they buy more stuff. There's also people thinking about fulfillment. How can we stack shelves better so that we can faster fulfill needs? Do we stack it differently on Christmas time or on other holidays? There's delivery, like how do we deliver in different areas of different countries? And there's payment, like do we accept credit cards, or what about PayPal? All these things. These are different mental models, and there are experts for those, and they don't need to understand the other models, right? So a person who is optimizing advertisement needs to understand human psychology and what our business actually tries to achieve, and combine those to make a good advertisement. I don't need to understand anything about payment in this context. So this is in the problem space or purpose space, what we call a subdomain. From the whole domain of online retailment, we have a subdomain of shopping or advertisement. Now, the bounded context is from the solution or proposal space, where we propose different solutions to solve problems in the purpose space. Ideally, the bounded contexts map one-to-one on the subdomains. So if there's a subdomain called shopping, I want to build a solution for it by naming it the shopping context. Let's build a software that is for shopping, great. And let's build a software for payment, also great. Now we have mental models in the solution space, matching on the problem space perfectly. Anyone has an idea why this would not be possible? What would drive you to have a different bounded context or a different solution space than you would structure your purpose space? If you have, write in chat or just speak out loud. Okay, so let me just give you a few examples. If you have some more, feel free to put them in chat and I'll discuss them later. So one of the reasons would be you already have a system in place, right? There is a legacy system involved. Let's say you already have an ERP system that is part fulfillment, part payment, and that's just in there. This system is from an external vendor, and that is part of your solution, of your of the way of you how you build the system. So even though you understand that the problems are very separate, now there's already a solution in place that defines a part of the map. So your strategical proposal that you can make of how to solve the business problems can't just freely say, hey, payment and fulfillment are separated, because you're already using SAP and it's in the middle and it's doing both already, but you can work around the still free parts. That would be one reason why the bounded context map does not look like the domain, like the subdomain map. Another one would be model size. The business people have been experts for shopping for over 10 years. They studied this stuff and they are experts in nothing else. You're an expert in software development. You can't expect to get the same depth of understanding in just a few months of modeling and building software, but you can chop up the subdomain into smaller chunks that you can then propose solutions for. So if the model doesn't fit in the head of the developers, make it smaller. Maybe shopping cart is one model and advertisement is the other model, or the suggestion engine. And then you can call your bounded context suggestions and shopping cart, even they are both in the same subdomain. So what we do here is we build a bounded context map that maps out all the solutions we're proposing. And inside of these bigger topics, these so-called bounded contexts, there will be detailed models with code and data structures written in the language of the business. And the relationships between those bounded contexts are clearly defined and very narrow. So let's say shopping, payment, delivery, fulfillment are our bounded contexts that we have in our solution now. If I work in the shopping team, I have a relationship to all the other teams. And of course, we need to have an API technically, but also organizationally, right? We need to understand if I'm changing anything in shopping, if we go from, hey, this has been ordered as an event to a GraphQL call or to a REST call, if we add more fields or change the kind of information for technical or business reasons, we need to understand how to talk to fulfillment or delivery to make this change also happen in the other system, in the other part of the system. And to make this viable, first thing we need to do is to map where is our core domain. So there is a term there's three categories of bounded context in domain-driven design. One being core domain. The core domain is our key distinctive domain. This is how we separate ourselves from the market. And let me make this a green one. So core domain is how we separate ourselves from the market. This is our distinction value. This is where we want to put the smartest brain of our company, the smartest teams. And then there's contexts that are supporting and not core domain. A supporting domain, on the other hand, oh, that went well. A supporting domain is still unique to our business, so we cannot just buy it off the shelf. We can't buy a fulfillment solution. It needs to be built by ourselves. It is supporting the shopping experience, so it's not driving our business. We are not in the world and in the market to build the best fulfillment. We are here to build the best shopping experience and to sell most stuff to people. But to make this happen well, we need a fulfillment context that is working well. So this is a supporting context. And I assume that pair delivery would also be a supporting context, given that we're Amazon emulating here. Well, payment again, payment is what we would call a generic context. A generic bounded context means it is a generic problem that is not specific to our domain. That's not really readable. That's more readable. So a generic context is not specific to our domain. It is something that many domains have. So let's say you are a cinema and you sell cinema tickets, you need payment. You are an online retail service, you need payment. You are any kind of company that is selling trainings or selling anything, you probably need payment. So of course, you can still build your own payment solution. You're free to choose to do that. But because you are here for having a better shopping experience and delivering faster, you can get PayPal or any of the other payment providers. It's a generic solution, so you can buy it off the shelf. So this is how you categorize your bounded contexts. And given that you now know what your core domain is, you get a good feeling of who should own the communication model, right? So what we do in the bounded context map is not only mark what's our core supporting and generic domains, we also model who owns the communication or who has most leverage in the communication. So the simplest kind of relationship between two contexts would be upstream, downstream. Meaning if you put something into the river upstream, right, the people downstream are affected a lot. If you do it the other way around, not so much. So shopping is core domain. All in a, of course, just imagined business here, right? Every business is different. So there is always a bounded context that is your core domain. It doesn't have to be one single one. It could be two or three, but let's start with one. You have a core domain And if you want to change anything in your business, usually not the fulfillment team will be the ones proposing all the changes. Hey, I have an idea how to make fulfillment better. Hey, we can improve this. Let's change to an app. Let's change this. Let's change how we interact with shopping. If that's the case, you have a mismatch. You realize from a business point of view, you want to optimize shopping. But if you look at the developers, fulfillment team is going wild. And shopping people are like, nah, bug fixing. And then you realize you have a problem. So mapping out the status quo and the status where you want to be can also be very valuable, making more than one context map. But if you have your context map, mark out or make it visible how the relationship between two bounded contexts is. So upstream, downstream means the shopping team, when they want change to happen, the fulfillment team is a supporting context. They want to make that change happen. They want to help the shopping to be better at the market, because that's why the whole company exists in the first place. And the other way around, if fulfillment says, hey, we need this technical change for reasons, we updated our API or whatever, then they know, hey, we can ask the shopping to implement this into their update next month or so. Or we can ask and say it's urgent, but they determine the pace here because they are upstream. Now, for many reasons, core domain is not always upstream. For example, if we say we have bought our generic payment solution, we bought PayPal. We have a PayPal account now. So we're not upstream, even with us being core domain. If we want to change the API, we can't just dictate how it should look. PayPal is an international company, and who are we here, right? I mean, of course, Amazon might be at an eye-to-eye level, so they can actually ask for changes in the API. So there might be not an upstream, downstream, but maybe a pairwise or at least a customer-supplier relationship of a different kind. But yeah, so how much or how exactly the upstream-downstream relationship plays out, it's important to map for two reasons. Reason number one, this manages expectations. The people in those teams understand where they are in the whole scheme of things, and they can map, hey, am I where I want to be? I want to be at the bleeding heart of my company. I want to push us forward, but I'm working in fulfillment, and that's not core domain. So yeah, maybe change something. And if I'm working in fulfillment, I realize I'm not the one, or our team is not the one to push changes all the time. It's a shopping domain that pushes changes, and we need to adapt to make their experience better. That's why we exist. So it's managing expectations, and it's also giving you a tool for planning architecture and team structure. So these are the trivial markings, upstream, downstream, or pairwise. Let's say here, delivery and shopping are pairwise. So they eye-to-eye level, they either succeed together or fail together. There is no one having more power or lesser power. These are the abstract definitions. And if you read the DDD book or go to any of the other DDD talks that go more into bounded context mapping, you can refine these relationships with different qualities or different levels by saying, hey, it's a customer-supplier relationship. This metaphor holds more information, or it's an open host service, or we have an anti-corruption layer here. Marking the specific nature of relationship is important because if you think about it, Conway's law, right? The way we interact defines how our systems operate, and this also pushes back a little. So you have a bidirectional relationship here. Your team structure influences your architecture, and your architecture influences your team structure. Not having a transparent map about that means you're set up for failure, or good luck to you. Maybe it still works, but then it's just dumb luck. So if you use bounded context mapping or nice colors like I do, or do any other kind of visualizing, but you need a map of your company and of your team structure to understand from a business point of view, are we actually built up for success, mapping towards the domain that we're trying to solve problems for, or are we misaligned, and therefore now we understand why it's always hurting and friction and yeah. So let me ask the moderators, are there any questions so far before I continue with the next topic? Oh, that's a good comment. Yeah, I just saw the comment. Delivery can also be a generic context. What characteristics makes it a supporting context in our solution? Well, that totally depends. If it depends on these things. If what you do with delivery is specifically optimizing your core domain, for example, if it's tied to the way how you do business, then it's a supporting context. if you say, if I am like any kind of company, I'm just doing something, I knit new cushions and I want to sell those cushions to anyone, then delivery, of course, is a generic problem. I just get UPS or any other kind of service and then ship my stuff. But if you're Amazon, you are optimizing things on a level that you can't just ask of the other deliverers. So Amazon is playing with, hey, you want same-day delivery? On the shopping side or the advertisement side of things, specific products allow for faster delivery. You can say, I want everything at once, or I want it separated. So fulfillment and delivery also have some kind of relationship there. You can even say, I want to have it within 2 hours, and then a drone will deliver it, as long as you live in New York or other bigger cities where drone delivery is a thing. And all these things are completely tied to the way they do shopping and customer management. So if you are a Prime customer and you pay for Prime service, you get different delivery methods than if you're not. So this is nothing you can buy off the shelf. You can't just say, hey, I have a Prime customer, so now UPS will do the following for you. Like, no, there's no relationship there. So if you want to model the behavior in any way specific, driven by your domain or your business needs, it becomes a supporting domain. It could even be, in theory, something that is very valuable as a supporting domain, but you still decide to make it a generic domain right now. So let's say in the early hours or in the early days of Amazon, delivery would have been beneficial to have as its own bounded context, but you only have one team of software developers, and they are totally focused on the algorithm to advertise better stuff. So it's not your main priority right now. You make it a generic context, you buy it off the shelf, and you just use whatever service exists. But over time, a year or 2 years later, you realize the core domain is growing fine, and we have more developers now. So now we can start thinking about how can we optimize delivery, and all of a sudden it becomes a supporting domain. And then you need to change. How do we get from our generic implementation, send everything to UPS and we're done, to, hey, let's build our own little thing in front of it. And what you would probably do is have your own bounded context in between UPS and your shopping for a while until you can push UPS out and you have your own delivery system totally or whatever. So, but this is now totally depending on the company structure and strategy. But a very good point here that you didn't ask, but that fits your question. So I hope I answered your question. A very good point is we said shopping is core domain, and it is for now. If you think about Amazon, it was a shopping system, right? They were advertising books and then other products later. But at some point, warehouse organization or fulfillment became their core domain. The shopping just worked. It was still there as people optimizing it, but it's not the core differentiator anymore. It's something that is maintained, and it's maintained well. It's a cash cow, great. But that's not where the company tries to excel. They fired humans, integrated more robots. They got swimming warehouses and whatnot. So they optimized warehousing and optimized the hell out of it. So it was a core domain for a while at least. And if you look at Amazon nowadays, it's a software cloud service provider with Lambda functions and stuff like that. And selling stuff is just a hobby they have. So your core domain can change over time when your business main value changed. Yeah. Thanks, Ibi. No, Ilahi. So next question. So you mean during time, the nature of domains may evolve, become bigger or smaller though? Yeah, exactly. So your bounded context map changes over time. Everything in there can change. What your core focus is at the business can change over time, of course. The mental models you use to solve problems with can change over time. You had very small, distinct models. After a while, you realize, hey, this one small model is actually one huge thing. Let's split it up into multiple smaller ones. But payment, delivery, and fulfillment, we model them as 3 different things. We can just make it a generic thing with SAP and we're done. That's also fine. So we can grow in both directions. The important part is to do the modeling exercise. So every once in a while, and I'd say half a year or a year is on an average basis. If you are a small to medium company, if you do it once a year, a sanity check, do a bounded context map of your system, understand where are we, where do we want to go, and does this still reflect our understanding? Super valuable. If anything changes throughout the time, you realize, oh, the new map we're modeling doesn't reflect how we actually think we were or where we wanted to be. And then you can adjust accordingly. It helps you with strategy. So how can we scale up this architecture? Yeah, that's a good question. So I don't understand exactly what you mean with the question, because you can scale this up to any size. you can zoom out, right? And then you can use more surface. But I don't think that's what you meant. So usually when you have something like a shopping core domain, if it becomes complex enough, it can, of course, be its own domain again. And internally you can have, or if you have this bounded context, let's say like that, in your solution, you have a bounded context shopping. But this can be a very complex thing, and you can chop it up into more contexts again. Then in reality, you just have more bounded contexts. And this can become cumbersome, but this is nothing that DDD solves for you in a different way than any other modeling method. If the whole system you build is hyper complex, if you have 5,000 different mental models operating in your business, that's your business. And that can be a problem. What I would try to do is find ways or find areas where you can have a strong separation, only loosely coupled systems, and then separate whole chunks out of it. So don't try to have 5,000 bounded contexts with a 10-company team or something like that. But yeah, this is, I think, a question for more discussion. So super happy after the talk to go into a one-on-one discussion. Please come on video and let's take this topic apart. Super important. But yeah, so it scales well in general. You can be as coarse-grained or fine-grained on your map as you want to be. With mapping, you always define, with any kind of modeling, you always need to define what you are modeling before you start modeling, right? So if we say we want to understand the big picture of our company, let's do a big picture context map, cool, then coarse-grained is fine. If you say we want to understand the finite, the minuscule details of our shopping context, let's go into the depth. Well, maybe event storming would be a better modeling method for that. But then if you derive a context map from there, it will be a very detailed one. But you don't need to do the whole company every time you model your bounded contexts. Okay. Yeah, thanks, Elahi. So good suggestion is reading articles on core domain patterns. There's a book by Eric Evans for free online. It's a PDF called Domain-Driven Design Essentials. And it has all these patterns in it. So I'm going to post a link after this talk, or if anybody wants to Google it throughout, please put it there. DDD Essentials by Eric Evans on domainlanguage.com or somewhere. Yeah. Okay, last question that I'm answering here before I continue is, what's the difference between subdomain and bounded context? Okay, this is a very important one. The subdomain is from the problem space. So it exists whether you build software or not. And I don't like the word problem space because the business side of things is not problematic. So I like purpose space more. But the usual term you can Google for is problem space. That's what people use. Let's say purpose space for now. So the subdomain is from a purpose space. This purpose of your business that exists without building software. You sell stuff to people. You want to deliver the things to people. There's payment. So there is purpose in your business of delivering stuff, capturing money, advertising better. And those purpose spaces are models that exist. So these subdomains, are models that exist whether you build software or not. That's just how the business operates. You as a software developer propose solutions now. You say, hey, we can build a website for this. And then you have a bounded context. You need a clear defined model to say this context is a shopping cart model. Everything about shopping cartism is in there. That's my bounded context I call shopping cartism. And then you have advertisement and brain manipulation. That's another bounded context. Both belong into the shopping subdomain because shopping basically has both in one mental model. But in your solution, you build two different bounded contexts because a team of juniors can build the shopping cart, but you need a team of highly specialized people to build the advertisement and brain manipulation engine. That's why your bounded context in your solution proposals looks different than the subdomains. So subdomain is a mental model from the business side of things, and a bounded context is a mental model from the solution side of things. Can be software, will be most parts, but oftentimes sometimes it's also not software, but just organizational changes or something with letters. Yeah. Okay, awesome. Let's continue. If you have more questions, put them in chat or on sticky notes or somewhere. We'll talk about this later. Now I can full screen again. Yay. Let's talk about Cynefin. Well, this is a Welsh word from Wales. Cynefin. There's a complexity theorist called Dave Snowden. He and some other colleagues study complexity and came up with the Cynefin model of complex systems that separates complexity into 4 different domains. So there is obvious complexity on the bottom right here. And obvious complexity means you have very tightly constrained systems. There is best practices you can use, and what you do is you sense, categorize, and respond. So what does it mean? That means I'm a German, and I sense the beer is empty. I categorize, lethal problem, and there's a best practice. I send him, hey, get a new crate, put it on there. Awesome, problem solved. So in obvious problem spaces, you have easily understandable cause and effect relationships. So there's this problem. When I do this, the problem is gone. This is how we do it. There's best practice. Amazing. This is where juniors can work almost freely or with very easy tasks that you can give them. This is also where you don't need experts. There's best practices. You can just implement them. There's complexity. So the complicated domain means you need expertise. My car breaks down on the street, right? I'm not an expert in car mechanics. I have no clue what to do. So I can look under the hood, but then I need to analyze. So you need experts who studied stuff or who have a lot of experience, who can collaborate on problems. And what you do is you sense, oh yeah, there's steam, it's heat, this is making weird sounds. So analysis says is one of the three problems here. And then I can respond by picking trade-offs and choosing methods. This is where good practices exist, but no best practice. In a complicated domain, and I think that's where most software actually lies, there's no best solution. There's only trade-offs that you can pick from. So there's governing constraints. You have certain things that set your boundaries of your solutions that you can propose. And you have a tightly coupled, clearly understandable relationship between cause and effect. It's not obvious. It's not like anybody can see if you hammer the toe, it hurts. Awesome. But if you have enough understanding and analysis, you realize there's a chain of cause and effect. And if I do this along the line, this will happen. Great, let's do that. Let's take this trade-off and walk here. And then there's complex scenarios. The complex domain is when you have interacting systems that interact with other systems. So whatever you do, there is no way of analyzing the outcome up front. Because of ripple effects and chaotic interactions and even feedback loops that turn back on the actor, let's say the European fiscal system, right? One of my favorite topics. If you change anything in the fiscal laws because you want to optimize how society works, great. You have no clue what's happening. You can ask anyone from people in the bar to people in politics themselves. Nobody can analyze the situation, even if they have 10 years of time and all the data available, because it's chaotic. You change a law, other countries will change their laws differently now in response to your change. Companies will invest their money in different areas now. Private people will start getting their money from the bank or investing in companies or just don't caring. There's a lot of things happening, and all of these things have ripple effects. So there's a feedback loop that change how you wanted to and what you want to do with next. So there will be never the same situation twice. You can't analyze, understand, and then respond. You can only probe in a scientific sense. So you can have hypotheses. Hey, I think when we do this, this might happen. And then you make an experiment and try to learn how it really relates. So there is a very loosely coupled relationship between the systems and the cause and effect relationship. So in hindsight, things might be obvious why they were this way now. But then you're in a different situation and you cannot just do the same thing all over again. In complex domains, you need to be scientific, probe, sense, respond. And if you can do multiple experiments in parallel, that's even more awesome. You can learn faster. So this is where small controlled experiments shine again. And this is also where software development really becomes valuable, because complicated domains exist a lot. Most of software solves some complicated problem, but that's the part that everybody can build, right? Oh yeah, I need my photos stored. I need my database sorted differently. Great. Let me build a tool for that. That's boring work. You can do that, but it's not really valuable. Solving problems that nobody solved before, that's where it gets interesting. And then there's chaotic domain. In the chaotic domain, there is no cause-effect relationship, even in hindsight. You are in a chaotic situation without any constraints. Everything is decoupled. Your act and the resulting effects aren't in any relationship that is understandable. So this is where you can only act. This is when novel practices emerge at some point. Let's say on the negative side, the burning building. Your building is on fire. There is no complex situation where you can understand and try to make experiments. Like, you need to act. You just need to do something, and afterwards you can try to understand what happened and and you can manage, you can just put fire on. Sometimes it works, sometimes it makes it even worse, shit. But you are in a chaotic environment with no time to reflect or experiment. So that would be chaotic with novel practices. On the positive side, it would be you want to build a colony on Mars. Nobody ever did that. There is nothing on Mars so far. So being the lunatic type of, hey, let's build electric cars and then some rockets and then build a colony and then live there, that's chaotic. You are unconstrained and there is no boundary where you can actually experiment within. This is novel practices emerging from here. So the whole point of the Cynefin framework is, of course, not to define, hey, my bounded context exists in these different complexities. Now we have a new name. But if you understand the level of complexity that your system has, and by system, I also mean just the bounded context, not the whole system. Some contexts are complex, others are pretty obvious. That determines where you would put your core domain and where you would put your smartest developers and what part of the system need more rigor, more testing. It also gives you new boundaries of where to cut your system, right? Let's say shopping is a bounded context. In what complexity domain does shopping belong? Well, if I think about it from my perspective as Marco, it's an obvious problem. I have a list of all the products that you have. I put them in shopping cart. I order them. Dunsies, that's a very easy thing. From Amazon's point of view, it was a complex thing. Well, maybe complicated, but I think it was complex because it's about advertisement. You have the whole globe to advertise stuff to. Different cultures need different advertisement. It depends on time. Different holidays in different countries have different needs of advertisement. People buy something depending on their whole life context. If my wife is pregnant, she's just looking for different things than if I'm trying to start a company or if my wife starts a company, right? So whoever is doing what in their living context, they have different things that need to be advertised. Building a machine that is doing that is super complex. You have no clue of how this interacts. And when you start doing that, you reflect on the behavior of people, right? If I realize I'm being manipulated by your engine, I try to manipulate your engine to sell me the stuff that I really like or stop advertising things that I don't like. So it's a complex domain. But the shopping cart still is just obvious. So now I know that my shopping context shouldn't be one bounded context. There's one obvious part, the shopping cart itself, and there's the advertisement engine that should be probably a complex thing. So I make it two bounded context just so I can distribute my teams differently. And of course, all the systems over time go clockwise. If there's something chaotic, it becomes a complex problem at some point. If something is complex, it drives to be a complicated problem at some point. If it's complicated long enough and you have enough analysis, at some point it becomes an obvious problem. This is the natural direction stuff works in. But also the problematic thing, if you have something that is obvious and you never sanity check it, at some point, the market might have changed underneath you without you realizing it, and the obvious became chaotic because you think you are in situation A, but you are in a very different situation now, so all your assumptions don't work and your best practices fail, and oh shit, everything is on fire again, you need to throw the water everywhere. So yeah, that's Cynefin for you. How I use Cynefin in every day is basically when I am on my, wrong direction. Second, when I am on my bounded context map here, I try to understand how complex is this part of the domain. And if we have a discussion with the business people and the domain experts and realize, oh, that's not one level of complexity, there's different things are different complex in there, that's a good heuristic to maybe cut your context solutions into, again, different bounded context. So how can we refactor a monolith that already exists into microservices based on bounded context? That is a very good question. Let me go directly to that question. So Cynefin is done now, the topic. It is just one more heuristic, one very valuable heuristic to use to actually separate your context. If you already have let's say a big ball of mud, you have your legacy system that is a huge monolith, trying to model your business without having the monolith in mind is important. So I would do a big picture event storming. We'll talk about that in a few moments. I would do a big picture event storming to understand how the business is actually working and then separating mental models from there from a domain point of view, not from a technical one. And then when you have your bounded context map like this one, where you understand the actual business models and then their relations, Then you can map, how does our monolith work at the moment? Okay, everything's in the monolith, great. But what is our core domain? Well, let's say shopping is our core domain. Can we separate shopping from the monolith? So let me try here. Maybe I can even draw live. Yeah, that should work. Let's take a blue one, a bit thicker. So let's say you have the monolith here. All of this is your monolith. And now you see you have 1, 2, 3 relationships into your monolith. What you can do now is building an anti-corruption layer. So you could say, I have this, yep, drawing with the mouse is awesome. You have an anti-corruption layer here, here, and here. You need 3 adapters into your old system, into your old monolith, that simulate the docking to the old shopping system. And of course, inside of the monolith, it could be that you need here, here, here. You have a lot of complexity now that needs to be kind of dealt with while you extract parts of the system. But with a context map, you can actually plan out, we want to extract this bounded context first, make it a clean model, because this is where our actual value lies. We can't rewrite the whole system at once. That takes 5 years. And afterwards, the new system is the legacy system again. So, oh, sorry, but yeah, don't do that. That is always going the wrong way. Total rewrite never works. You can cite and quote me there. But you can rewrite a bounded context. You can build a small system that is now projecting information into the old system. And you don't want to model your old system with dependencies on the, you don't want to build your new system with dependencies on the old one, right? So the anti-corruption layers, I actually drew them on the wrong corner here. They belong here at the boundary of the new context. So the new model doesn't know that there is an SQL table, and here is like these 500 lines of code, and this is just garbage. And the new model is pure, it's clean, it's event sourced or domain driven in any way you want to build it. It only has clear language and clear technical dependencies. And when you call a method here that says, and now require payment, the anti-corruption layer is doing all the translation into, okay, that means call this object, go to this database, call this weird enum and the magical number 53 at the end because legacy systems, right? And then you build all that into the anti-corruption layer. At some point, you can say, let's now, next step would be take the payment out of the, oh yeah, that went well. Take the payment out of the old monolith. So now we do this. Now let's strap the payment out of it. And then what you can do is you can get rid of this anti-corruption layer, because there's an actual relationship. It doesn't work here. There's an actual relationship between these two contexts now, but both now have a relationship into delivery that is still in the monolith. So step by step by step, you can rewrite things. At some point, you might realize it's not worth it to actually get rid of the whole legacy. Some part is just still working and it's working okay. Rewriting it will take you a year and there's no gain in there. So you can make that choice. You can have a nice, you can have a nice bounded context for payment, another nice bounded context for shopping, and both contexts have clear message contracts and whatnot, but they're still part of the legacy system working with a clear anti-corruption layer. And that will never become a microservice. That's just your monolith as a microservice. And you're done. Okie dokie. Good question. Thank you. Okay, so from Kinevin. With the Kinevin example in mind, we realized that there's organizational and technical boundaries, and they should co-evolve by feedback from the vision, the product, the export location, bottlenecks, complexity, data cohesion, domain and code. And this list is not ending here. So what this whole wall of text should show you is there is no easy way to come up with a good bounded context map. There is not like 5 rules you can do and then you have your context map, the best one. Every context map, like every model, is wrong, right? You can only try to get to a good understanding that most people agree upon and then say, let's commit to this solution until we figure out a good reason to change it. So when you have a bounded context map and you ask the business people how it should look, it will be their subdomains that they have in their mind, their business vision. But then you realize some parts of this sell better, others sell differently. So maybe the structure changes because of how to place a product in the market. But then again, because there's already a piece of software written that is already a bounded context, yeah, your map doesn't really reflect that. So your map changes. Then you realize there's complexity involved, different layers of complexity in different systems. Whatever the reasons why you want to split a bounded context model into multiple or merge them, there is no right or wrong reason. It's all about consensus. If you as a group of customers or domain experts, stakeholders, programmers, if you realize this is a mental model that we as developers understand, the business people agree this is a mental model that we agree upon, you can build it. So finding a good context map with the highest level of agreement that you can commit to is the goal of the modeling exercises. And it's not easy. It's not like you can just do this 2 times and you're an expert. You need practice. But on the other hand, it's simple to start. You just need practice. Just start. And even if you don't come up with a good context map in your first modeling session, in the conversations to build a good context map, there will be so much learning happening. And if you remember Alberto Brandolini's quote, right? Software becomes what the developing team understood, not what business people meant. You can make that more cohesive by modeling and building a context map. Okie doke. So there's one team per bounded context. And that, I think, concludes also the strategical part of DDD. So this is how I would draw my bounded contexts. I have a team in here. There's a team of developers and business people, domain experts and developers per bounded context. And they speak one language in written documentation or in the code base. And this language is ubiquitous language that we will talk about next that reflects your understanding of the business problem. That does not mean that you need one team per bounded context. There can be a team that owns all the bounded contexts, of course. A team can have multiple bounded contexts, but you cannot have multiple teams that work in the same bounded context. If you really think about it, it's quite trivial. A bounded context is a mental model. This is a mental model that you build to solve a problem. If you have 2 separate teams working on the same mental model, they are by definition one team now, because it's one cohesive group working on the same mental model. If it's 2 teams who pretend to work on the same mental model, but they never talk to each other, they are not working on the same mental model. They might work on the same topic, but it's 2 different mental models. So you can only have one team or one cohesive group of people working on a bounded context. And for practicality reasons, most companies have, most teams have multiple contexts they work on. But this depends on the size of your company and the scale of your problems, of course. So this is also one of the questions, how can you scale this? This is how you scale this. This leads to a team structure immediately and also to an architecture suggestion. Okay. Yeah, good question. Can you recommend a learning path for those who are starting to learn about DDD today from YouTube? Okay, I hope you're not learning DDD from YouTube, but you are on YouTube right now, so kudos. I said this in the beginning, and let me repeat that. The virtual DDD website, if you go to virtualddd.com, in the menu, you'll find a link. The second link next to sessions is Learning DDD. If you click on that link, that's a curated list of the community of how to start with learning domain-driven design. From my personal experience, starting with event storming as a modeling method is always a really good way to go because it's an easy thing to start. You can use a mirror board or you can do it with paper on your wall. It just involves talking to people and a very simple grammar. We will do event storming and talk about event storming in the following slides. But yeah, starting with an event storming is on the strategical side, always my go-to. And of course, the major benefit, it lowers the barrier of talking to business experts. So the developer, domain expert communication becomes way easier when you do event storming. And it also fosters more psychological safety in the whole process. But of course, you don't always have access to those people immediately or don't have a facilitator who can moderate that quickly. But yeah, event storming would be my go-to way. And on the technical side, it's using value objects. Refining your code base by using domain terminology, by starting using value types, which will be, I think, the exact next slide that we talk about. That is the easiest, the low-hanging fruit of DDD on the implementation side of things. How to do DDD as a whole, the learning journey, there's no clear-cut path that everybody can go because it depends on context. It depends on how your company is structured. If the drive to do DDD comes from management or from developer side, So there's guerrilla tactics you can use. There is workshops you can do. So I would go to virtualddd.com and look at the learning journey there. That's basically it. Yeah. Some people also talked about DDD challenges and cons. So I suppose you mean the downside of domain-driven design or the challenges when you apply DDD. So yeah, that's an important topic. I will talk about this more at the end of the slide or the talk, but let me give you a few sneak peeks here. Okay, cool. Yeah, I got that right. So a few sneak peeks of what the challenges would be. If you try to implement domain-driven design in your company, DDD is a methodology. No, it's not a methodology, it's a philosophy, right? It's this gravity well of ideas where all the things go into. So trying to get DDD right is one of the major sticks that goes wrong. If people try to understand DDD first fully and then implement everything, that doesn't work. Because it's so many things and not really anything at all, there is no full DDD or perfect DDD. Don't try to be perfect with doing it. It's if you take it as a heuristical North Star, go towards more DDD, that's easier. So trying to be perfect with DDD is one of the big downsides. Then the adoption has a few problems. Many people out there read about the tactical implementations. They read about aggregates, entities, value types, repositories, and now they do DDD. It's not that they're not doing domain-driven things now, but they missed the point. Doing those implementation details is the thing with the least return on invest. It's the least value you can get out of DDD. The whole point is to be domain-driven in building your solutions and adjusting your code so that it reads more linguistically in the domain. That's good, and those patterns help with doing that. But applying them because they are DDD and not doing anything else, that goes in the wrong direction. Then you just have more complexity in your code without ever learning really anything about the domain. So there's a lot of people out there, even consultants, which is dangerous. There's a lot of people out there teaching DDD, talking about DDD, and what they actually mean is just implementing things in a certain way. And that's always a big no-go. If you realize people do that, ask them to join an event storming and talk about the strategical and modeling parts, because it's more about the modeling and understanding than about how to implement with what architectural patterns or so. And yeah, so that's one big problem. Now the last 2 points I want to hint at is, if you do DDD from a programmer's point of view, and you as a programming team try to introduce it into the company, but the company didn't ask for it, there is no business person or manager or senior higher up, whatever, asking for, hey, how can we be better at this? Then what you're basically doing is you are violently trying to impose change on how they should work. And they usually violently try to defend their old ways of working. So this has an adoption problem. There's a cultural friction happening when you try to get rid of business analysts or rewrite their roles to make them facilitators in communication between business experts and domain developers. If DDD comes from higher up, if people from the management architecture or so side say, hey, we need to do collaborative modeling and all these things, we heard good stuff about event storming, let's try that. You very often find developers who think like, yeah, but I want my UML diagrams. This is how we always build stuff. I need to understand what to build, how to build. The why to build, I don't care so much about. And that's also a problem. So both things there's no easy method to deal with that. But again, psychological safety, super important here in both directions, no matter which path you take. And this is why I like event storming so much, there are ways to just tease topics and to make people interested without being violent in forcing them to do something. So when I, as a developer, try to introduce guerrilla in a guerrilla style, I try to introduce event storming, for example, I don't invite people to an event storming session. I just take some sticky notes and I say, I have questions. And then I start doing an event storming without calling it that, and ask the business people for their opinions, and I write it down in events, and then they see what's happening and they will add their own stickies. Then at some point they just adopt the method because it works so well. So yeah, small controlled experiments in either direction. But that's something that needs endurance, expertise, you need psychological safety. It's something you need to build and foster. So yeah, there's a lot of things that can actually make DDD hard to implement. And don't suppose it will work with the whole company. DDD is a great approach at the whole company thing, but if you start doing it and there's part of the company saying, I don't care, SQL is all I know and all I do, and they don't change, yeah, well, you can make a bounded context around these people and say, look, let's protect that team. They can do this kind of work, but there's a clear anti-corruption layer. We don't want to deal with them. We only deal with the abstraction, and that's it. Yeah, the rest is it depends. This depends on so many things, but there's a lot of downsides to DDD. Also, last point, I swear, DDD is costly. If you do the full approach, strategical, modeling, understanding, separating your systems, complexity analysis, architecture and secrets, event sourcing, and then all of these things are costly. So you need to learn that, you need to maintain it, you need to invite people and have all these discussions. That is hard to do. But you don't need to do it all the time. Understanding you need to understand your customers anyway, right? So using some DDD methods to understand where to use the rest of them is super helpful. So modeling, I would always do. The rest depends on what I learn from the modeling process and then adjust accordingly. Yeah, okay. So one team per bounded context. That's it about the strategical domain-driven design. Yay. Now let's go into the technical parts. Ubiquitous language. Ubiquitous language is the second biggest pattern from DDD. Bounded context and ubiquitous language are the both new topics in domain-driven design. Ubiquitous is a nice word. It really flows off the tongue, right? Ubiquitous language means you have a language that is everywhere in the domain or in the specific bounded context, in the heads of the developers, of the business people, in the written documentation and in code. And if you are an object-oriented programmer like I have been most of my life, you have seen things like this: a privacy manager delegate, thirst quencher container, an entertainment provider singleton, amazing stuff. Like this is how we as object-oriented programmers divide the world into classes of things we can see in the real world. Let's put them into code. We have a problem here, of course, because we have the singleton, the delegate, the decoration, the container, the view controller. Those are all technical patterns, and they do not matter from a business point of view, from a domain point of view. This is what we call weasel words. There's multiple categories of weasel words. There is, you have the Hungarian notation, right? You call the data type inside of the variable name. You have the int h or the decimal value or something like that. You have the abstraction that makes no sense, like you have customer data or customer DTO or meta customer or basic customer. These words can mean anything or nothing. There's no meaning to it. But you find that so often in code because people say, but I need to know what this is. But you really don't. The entertainment provider singleton. Do you care from if you write business code if it's a singleton or not a singleton? If you really want to know what it is, you can jump into the class, look at the implementation, right? You can also, because we have modern IDEs, you can make it a marker interface or annotate the class or write a code comment, God forbid. I mean, there's so many things you can do to make it visual what this is without writing it in the name. But if you try to read this, let's imagine you read something like Harry Potter and there is the Harry forename, Potter last name person walking down the street object to the meta Hogwarts. Like, this is not how you read a story. This is boring. Your brain always needs to filter between domain, technique, domain, technique, domain, technique. And as developers, we don't realize it, but this makes our brain tired. If I can just read the story without these words, that's great. Let's get rid of the weasel words. But then again, a thirst quencher, a living space separation, those things aren't really the ubiquitous language, right? Where's my mouse? It's these words that are the actual business language. So there's a picture of a nation blind, a glass, a television. Those are the terms we need to see in our code. And of course, these are nouns. The ubiquitous language doesn't stop at nouns. It is everything you can express in your domain. Use the language of the actual business people and don't try to put in the pattern names or the abstraction of things into your business code. Your domain model should be expressed in a way that business people would be able to read the code, given that they can ignore the brackets and colons and stuff like that, right? They don't need to actually be able to understand coding, but you can write your code that is written like prose instead of like a technical description. That gives you, not only because business people would actually understand, but that gives you as a developer such an easy understanding of what's happening in your code. And yeah, period. End of sentence there. I was looking at the question. I got off track here. So Ashkan is asking, if we need to keep some models of one system in another system to discuss the autonomy of systems, how do we name these models in another system if we follow ubiquitous language? That is a really good question. Thank you. So if you have one system and you need to keep something from another system in your system, let's say shopping and delivery, right? They both have a delivery. There is a specific delivery of 5 products that needs to go somewhere. And in shopping, you need to send this delivery to the delivery system, and you need to keep track if it got there or not. And so both systems actually have this concept. But in every context, the language is specific. A delivery from the shopping point of view is a different thing. It's a different class. You wouldn't use the model from the delivery system because you don't want this high coupling. They have their model. It might be a class. It just might be a table in a database. It might be some other structure. You don't care. What you have is some kind of API, some contract, how you can represent this. And the usual go-to would be represented with something that does not have a natural representation. So Uuids, for example, take a Uuid, a 16-byte key that is unique in the whole universe. Just take a number-letter combination and say this is this specific product. The shopping context is creating it, saying, hey, here is a delivery, and you send a message, let's say an event or some kind of querying object or a REST call. You send a specific message to them, and this message or this contract, how the interaction works, needs to be understood in both contexts, but only that, nothing else. And if you have like a pairwise relationship, this is like a one-to-one. You both understand the same message. But if it's like an anti-corruption layer situation, if there's an upstream, downstream or so, you can build an anti-corruption layer where you send a message to the anti-corruption layer, and the anti-corruption layer will then translate it into something that the other context understands. So both contexts can keep their own model. They can both reference the same physical thing, the same person or the same delivery, but you do not need the model of the other party in your own model. You just share some information at a given point in time or via a given technology. Okay. Someone is also asking, can I recommend for application DDD with akka actors? Yes. That was a quick one. So let's take this for later, right? Akka actors is a valid model to work with. It's not my favorite, but it works. CQRS event sourcing instead of actor model, I like more, but both are fine. We talk about those examples later on. But yeah, you can do that. Okay, so talking about language, ubiquitous language here. We have the ubiquitous language defined. Now let's look at a code example. So we have a customer repository, and usually I make this interactive, but since last time nobody answered, let me just guide you through it. We have a customer repository here, and it has a method called getCustomer by year of birth, and we need a datetime year of birth to return the IEnumerable of customers. Yay. That doesn't sound very domain-driven. If I speak it out loud, my mouth is like, all these technical words. So the first thing we can get rid of is the repository, right? Because the customer repository, what does it represent? Well, it represents the customers, right? A repository is a data abstraction from domain-driven design where you have clearly defined business language as questions. On the back end, there will be queries into a database, and then the data returns. So you as a domain never need to understand the abstraction of the database itself. The database itself. You only need to understand what you can ask from the repository. So customer repository dot get customer by year of birth. Customer repository, and here there's a weasel word. Repository is just what it is, but we don't care what it is. It represents a customer, so we could call it customers. Now we have customers dot get customer by year of birth. Well, customer is redundant. Customers get by year of birth is better. Then again, getters and setters are a plague in my eyes. Some people like and love them, especially Java developers often use them because many Java frameworks default use them, but getters and setters are not semantic. Every time something returns a value, you get a value. Every time you store some value, you set a value. That's nothing specific in there that has any value from a technical or domain-driven point of view in my eyes. So customers by year of birth would suffice. Then again, we have a datetime as a parameter and year of birth as a parameter name. We could just call it year. So customers by year of birth with the datetime year, better. But datetime itself is a bad data type, right? January the 1st of 1981 and January the 5th of 1981 are a different datetime. So if I compare this year of birth to this year of birth, it's unequal, but it's the same year. So why not use a date? Why not use an int? An int would be better, right? Well, but the int could be -1 million or 0 or +5,000, but those are not valid years of birth in my domain. So what I do is I build my own type called year, and it does a sanity check of, does this year belong to my domain? Internally, it can just be an int, but let's build our own type. And then we have customers by year of birth with year, great. But still, nobody talks like that. What people would say is, give me the customers born in year. That's how you talk. This is semantically different and so easy to read. When you read this in code, you immediately know what it does. It returns customers born in 1981. Cool. If you read this, as a programmer, you will quickly compile this in your head. You will understand what it does, right? It's totally clear. But then again, you need to compile it in your head first. And we do this line by line every day, thousands of times. This just takes a toll on our understanding of the business code. So writing customers born in year gives you way better understanding. So instead of having up here a repo saying is repo get by year of birth, new datetime, something, something, we can say turning 50 is all customers born in year of 1968. That's a good heuristic from DDD, from Eric Evans' original book called Model Out Loud. If you can read out loud your code and it makes sense to you, that's a good thing, because now your brain doesn't have to work to understand what's happening here. And if you put this pattern as the only pattern in your DDD handbook from the start, if you do nothing else but just better code in domain language, you gain so much clarity. And then you understand quickly why you want to model more, because now you realize by formulating the language, like, okay, but I'm trying to write these things, but it's all the same concept in code. Like, we're not really abstracting the correct way here. Then you have better conversations. This is steering into better conversations already, because you look at the abstraction and you realize, oh, this is not how I would say it as a business person. Cool. What would you say? Let's refine that language. Amazing. And that's a pattern we call refactoring to deeper insight. Whenever you learn something new, refactor your code, rename the classes and the methods to make it more reflecting of what you understand about the domain. Now you can see I say year of 1968 and not just new year 1968. And I'm very nitpicky there. You don't have to be, but I like to be nitpicky, because New Year is a holiday, January the 1st. Year of 1968 is better in language. So how did I do that? I built a value type. We said it before, that's a low-hanging fruit of domain-driven design. If you do nothing else, event storming on the modeling thing, yes. Value types on implementing, yes. So the value type here, I just build a struct, or you can build a class that is immutable, depending on your programming language, of course. Internally, we just have an int, but a year cannot be below 1900 or above 2200 in our domain. Healthcare system in Germany, we have the year 2021, so nobody will be born before 1900 or after 2200, other years. These years don't matter in our domain. So if somebody tries to construct a year like that, we throw a domain exception. That means whenever you have a function or a method in your code that needs a year, you don't have to do any defensive programming. You don't have to check for null. You don't have to check for an illegal value. A year can only be constructed if it's already constrained by adhering to the constraints of the domain. So I have my public constructor here, a method called auth, and it just returns a new year with the year in it. And you can, of course, override the toString method by giving it a human-readable format. So if you say, hey, give me my year to string, you get year of 1968. Amazing. It's a neat addition for testing frameworks and stuff like that. So value types, super cool, super easy. I've hidden a little detail here. You need to implement equals and get hash code, of course, but that's just busy work. You can code automate that, but that's something you need to be aware of. A value type, of course, has no ID, because the year of 1968 doesn't have an identifier. It's just the year of 1968. So you need to override the equals and get hash code methods. Yeah, with value types in mind, this is how my code looks. And I'm sure nobody can read it because it's German now. If you read German, welcome to my domain. I'm working in the healthcare system, and this is about how many vacation days you can get by law if you're a German healthcare worker. And all of these terms are German. And why are they German? Well, because our domain is German. So I would not abstract every term into an English term just because code is written in English usually, right? That would be bonkers. My domain has Berechnungsmodus nach Tagewoche. You're welcome. There is no English term that means exactly that. I can describe it in English, or I can invent a word that would mean that in our domain then, but that is misleading because the next programmer looking at this text, if someone already understands the business side, they will not find what they're looking for in code. But why not just write in the language that the business is actually driven? Now, many domains are English, especially if you build international software. Many code bases will be English, and then you just don't have this advantage. But if your domain is German or Persian or Italian or anything that's not English, you have two benefits here. The major benefit now is you actually understand the business better and you write your understanding in code. And when you learn more, you can refine it by using the actual language. So this is prose. I can read this from top to bottom, and there's a business story. Except these two words. Should be is my testing framework. I'm using fluent assertions here, but that's it. The rest I know is English, is domain. The second benefit is exactly that with the English words here. I can see if my methods are purely business driven or technical driven, or if I have a mix of both. Because in my domain model, there should be ideally only business language. In my infrastructure layer, orthogonally, there should only be English terms, right? There's only messages being sent, data has been stored, UI has been UI'd, whatever. There's like, you see business language all over. There's for each loops and SQL statements, all those things. And then there are some things like a command handler who's translating some message from the outside world into a call into my domain. So this is a thing where I expect both languages to mix, but only there. This gives you a sanity check. If you see some code that is English, German, English, German, English, German, or English, Persian, English, Persian, English, Persian, then you know, oh, I'm mixing concepts here. And then you can ask, why do I do that? Maybe there's a reason, and then it's cool to mark it, or there's no reason, then stop doing that because abstraction, right? So enough with the German here. So yeah, this is the only new thing in DDD. There is one ubiquitous language per bounded context. None of the concepts from domain-driven design are really new. Everything has been done before somewhere in some form or whatever. The ideas from DDD, most of them are from the 60s, 70s, and 80s. But separating your domain into context and using a specific ubiquitous language per bounded context, that is what DDD entails in its core. And that is giving you the most benefit if you adhere to this structure. So you have one language per bounded context, meaning, sorry. So back again, meaning if you have a team of people, of business experts and programmers that talk about a specific thing, they don't talk about tables and buttons, clicks and stuff like that. They talk about business concepts. But the terminology they use in this context can be very different from the terminology they use in this context, even if it's the same concept or relating to the same concept. Let's take our example of delivery, right? We had this question before. If there is a specific delivery being sent, the term delivery means something in this context and in this context, but only in this relationship there is a message saying, deliver this package to customer XYZ with the following content. That message is something both parties need to agree upon. They have their own class delivery, they have their own class delivery or their own concept of it. What this term means is very different per context. And so you refine your language only on your own mental model. Everybody owns their language. Now, I have this exercise here, and we can now, let me zoom out a little. Look at this context map that we had. In which context does the customer belong, right? It's a good question here. So customer could belong in shopping because, of course, the customer is doing the shopping. Then again, you could say the customer could belong in delivery because I'm also sending stuff to the customer. Well, the customer is not in fulfillment because customer doesn't care there, right? It's There's kind of relationship with the products, but not really a fulfillment to customer. But the customer also belongs into payment, because the customer needs to pay us, or in Amazon even, because the customer can also sell things, we need to pay the customer. Yeah, great. So we have 3 bounded contexts that all want to have the customer class. But where does it belong? And actually, in all of those. There is not a single customer class that belongs into one context. The customer in shopping, how does it look? Well, what do we have? We have an ID, and we also have a list of, well, let's call it of items, but let's call it a shopping cart. We have a shopping cart, and typing, and we also have things that interest us. So interests. This is kind of like what the customer entails, and there's of course behavior tied to all of these. You can add stuff to cart. You can say forget some interest or whatever. There's data and behavior to the customer. In delivery, customer has an ID and an address. That's it. Maybe not even an ID. Maybe it's just an address printed on the package. Well, here they have debt and they have credit, and of course they have an ID. And maybe, and so on. I'm not really modeling the domain here, but you have different classes in these different bounded contexts, and they're all called customer. Then, of course, the name of the customer at some point is probably another bounded context. So this could be the context of master data. In the context of master data, you have a customer that has an ID and a name and an email and so on and so forth. Make a beautiful circle around it. Yay, now you are also a bounded context here. Blurb, blurb. There you go. So master data is a bounded context that has a relationship to all of these. Now that went well. Using Miro is also an art that I'm not always good at. There we go. So now we have a master data context that has all the information that is for screens and printing. And then we have a shopping cart that has an ID, which refers to the master data customer. So this ID is in all the messages, right? But my model, what a customer is different. Now at some point you realize you don't have a customer in payment. You have a creditor. That's actually the name. And you also have a debitor. These are 2 different concepts. And you don't have debt and credit. You just have, you have debt here and you have credit here. So you have 2 different classes, and you can just change your model because it's your model. Payment has its own mental model, and they can change persistence, they can change technology, they can change class names. It's totally fine. The only thing they need to make sure is if shopping tells me this customer owes us because they ordered something, make payment happen, I need to understand what the ID means, and then I can see if I already have this customer or if I need to make a new entry in my database, but it's my model. So Mohammed is asking, in case of customer with different attributes in each context, then how do we need to model its data and its access? Do we force a coupling? Well, the unsatisfying answer always is, it depends. I built a bounded context map here for a scenario that I think makes sense. Master data, everything that is not owned by a bounded context, goes into the master data, just information. And this context now owns the data. The shopping doesn't care about the name. There is no rule saying you cannot buy this car if your name is Marco. And if your name is Mohammed, you need to pay more. Like, this doesn't happen. If that happens, then this name, of course, is part of the shopping context. Then the shopping context needs to own that information. Now, usually it's pretty clear where what information belongs because you always have a natural owner, the context, the mental model that is determining this information. But of course, sometimes multiple bounded contexts want to change the same information. And then it becomes hard. Then you have to look for other heuristics. Sometimes if you have a drafting model, for example, you have a document that you can draft, you can change all the time, but once it's done, it's drafted, then you go to execution phase and you work with this document, but you don't change it anymore. In both contexts, you need the same information. And up until a certain point in time, this context is owning that information. But after a certain, event happened, the other context now owns the information from a customer or from an outside point of view. Still meaning the context number one can edit the data up until a certain point in time, and then they cannot edit it anymore. That's it. The other context can't do anything with the information, but at a certain point in time, they can start using or editing this data. So they still have their own model, but now your whole system is built in a way that the handoff happens temporally. Now, there is no cookie cutter solution here. There's nothing that you can always do that always works. You need to find, and this is why we talked about the bounded context patterns over here. You need to find the context map that is driven by vision, product, expert location, bottlenecks, data cohesion, domain code, and so on and so forth. Find a model that works, because most of the time it's super easy, super obvious. Sometimes it's tricky. Sometimes it's outright impossible. That's super rare. And if you have that kind of problem, invite me. I'm happy to help. That's why I do my business, right? But also you can go to the DDD community, go to the Slack channel or the virtual DD space, interact with people and try to figure this problem out. If you already have some experience in modeling, do your modeling session and propose multiple solutions. At some point, when it's a complicated scenario, there is no best practice, right? There is no perfect model. Every model is wrong. Some are useful, and there's different trade-offs. Figure out what is a trade-off in this case or in this case. And yeah, sometimes you have redundant data. Redundant data is great for autonomy of context. Awesome. You now optimized for autonomy, but against stable information. There could be data problems in your system. Having non-redundant data is optimizing for stable data, but against autonomy of systems. Now they need to interact to make sure that things happen in a certain way, and this is coupling teams. There is no good solution. It depends on your problem. Do the people have access to each other? Can they talk easily? How's the trust level going on? How fast do we need to change our systems? How fast do we need to respond? All these things come together and then build a model that works. So what I always suggest here is, in this kind of modeling and in any modeling in general, build at least 2 or 3 different solutions that would work and try to understand the trade-offs of these very different solutions, and then decide on what you really want to use as your implementation. This also means I sometimes just code 2 or 3 different prototypes that are different from each other and throw them all away just to learn something and then decide on what I want to build in the end. Okie doke. So yeah, coming to the final things. This is the technical part of DDD, or this was the technical part. Now let's go to modeling. Well, we model. We talked about, looking at this again, we talked about customers and shopping and behavior and what you can do and how to order and depth and stuff like that. But if you talk with people, words vanish. If you talk and talk and talk, people just forget what you said. They say, but you said, and you say, no, what I meant is, and then at some point you start to discuss stuff that you discussed because you are in a loop of refining what you just meant, and this doesn't really work well, specifically if you have extroverted people and introverted people. So make your words stick. Put them on a wall, or if you are in virtual space, put them on a mirror board. This is where my most favorite modeling method comes in, event storming by Alberto Brandolini, again, from Avance Coperta. You create a shared sense of reality with collaborative modeling by putting all the stakeholders in a room or on a virtual board with Zoom and Miro or something, and let them collaboratively model out the domain. Event storming is a method consisting of 2 words. Storming is the easy part. That's brainstorming, right? Everybody starts at the same time. No ordered process. You just generate chaos with sticky notes. You get all the ideas out, and then you look for patterns and derive a solution that you can really build. And event, meaning domain event in this case. So you only model the words that, the events that are meaningful to the business. That means button was clicked or data was stored is not a business event, domain event. But shopping cart has been ordered, product has been sent, those are domain events. And you can go as coarse-grained or as fine-grained as you need. Again, it depends on what you want to model. If you try to understand the big picture of your domain, then you don't need, okay, I added something to the shopping cart and then it got moved in priority and then this and then. That might be too fine-grained. But products have been added to shopping cart has been ordered, payment has been fulfilled. Great. On this level of abstraction, you can model. If you understand the big picture already, if you have your bounded context map and you want to model a small piece of software that you really want to build, go to the fine detail, really make every little thing that can happen a sticky note and try to understand the business flow here before you build the system. So as you can see here, back before the pandemic hit the world, we did this in Hanover, a modeling session with business people and technical people. And you realize there's a lot of dynamic going on. Some people stand in the back, some stand in the front, some are eager putting all the stickies out. Others are learning about the domain for the very first time and just walk around and try to look at everything. And it's all okay. It's a big collaborative learning effort. You try to do big exploration up front, not big design up front, right? So this gives you a good heuristic for bounded contexts, because you see here, this is another company in Germany. After a long while of modeling, we realized, hey, look, there's a group of people over here, and those are 3 of the marketing people and 1 developer, and these are the people from the fulfillment team. But this is also a marketing person, and here's fulfillment and marketing teams and 1 user experience expert. So you have different groups of people standing in different parts of the model and refining different areas in the model. This gives you a good heuristic of where your bounded context boundaries might be. Also, you can see there's a lot of complexity happening here, and then there's only 1 or 2 messages and then nothing. So yeah, even the message flow that you can visually see give you a good heuristic of where your context boundaries might be. So just from a visual cue, this makes modeling so much easier by modeling the whole process in events, what can happen and what happens afterwards in a timeline from left to right. And you don't talk about technology, that's just about the process. And this already gives you a good inkling of how your software should look in the end. So I got the question here. Assuming you're working on a software that is used in multiple countries, initially the domain language was English, but then it developed an application English. And now to create a feature to solve a problem specific to a country, this country uses Spanish for the domain language. Is it a good idea to mix ubiquitous language in the application? It depends. But in your case, I would say yes, because in your bounded context of the specific domain model for the Spanish Inquisition, you can build something that actually helps them solve their problem. The outside world speaks a different language. So of course, if the Spanish context is sending a message to the English context, English might be the translational language, right? So either you build an anti-corruption layer around your Spanish layer so that the Spanish context doesn't even have to translate a message, but the anti-corruption layer is translating. And then inside of the Spanish domain model, you can have Spanish developers working on the Spanish domain and never think about anything English. Or you make a translational layer on the outside of that bounded context. So your model is completely Spanish. You can really solve the business problems in their own lingo. Perfect. But then when you say, and now we need to fulfill that order, you actually send an English message to the English system because you do the translation inside of your mental model. That depends on how the business people actually see their domain. Do they understand that there's a multilingual situation and is it part of their mental process, or do they only see their Spanish side of things and need to be protected from the English influence? So yeah, it's a good idea to do that if you actually have an isolated bounded context in Spanish, pure Spanish for Spanish country problems. Go for it. That's super cool. That is a benefit you can get from bounded context mapping, right? You don't have to define 1 language for the whole system. Every bounded context has its own ubiquitous language. Neato. Okay, second question, how do we fit REST APIs to ubiquitous language? What is common between behavior-driven development and ubiquitous language? 2 different questions. First one, REST interface and ubiquitous language is not a really good match. When you have a REST interface, from a domain point of view, I would abstract. I would say, here is my, let's say, repository pattern or any other kind of port and adapter pattern where you can ask questions in message form. You can say, hey, please order this shopping cart, or hey, fulfill this contract, or whatever. You're sending a message, and that message gets mapped into a REST call in some kind of command handler or event handler or message handler. You just have a technical layer that is taking the domain word, makes it a REST call, and that's it. Of course, depending on how you understand REST, some people say this is REST, this is not REST, right? I'm not taking any sides, I don't care. If you have a REST API and that is doing a put, get, whatever, you can of course have semantic meaning behind it. You can have put customer information, blah, 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 make it a long row of semantic words, including verbs. So you can be very domain-driven in there, but in your domain model, your domain usually does not understand REST. REST is not part of your domain. So I would always go for the simplest thing, that is, have some kind of message queue that is domain-driven. You say, hey, do this, and this message just gets mapped into whatever technique you're using. Let it be Kafka or REST or don't care. And that's the part that's important. Your domain shouldn't care about the implementation. The other way around, yes, of course, the implementation should make sure the domain works, but the domain shouldn't care about how it's implemented. And a REST call is usually an implementation detail. The other question was, how does behavior-driven development go with ubiquitous language? Very well. BDD, right? Given, when, then. If you talk about event storming here, and we'll look at an example, yeah, right here, the next slide. Let's say you have a list of events and commands, and let me just quickly give you an example. If you model in an event storming approach, and you say you have something like stack has been shelved, and you say cart has been opened, and then you have a command that says add stuff to cart, and then there's an event saying stuff has been added, and so on and so forth. So you are writing your complete domain, and you model it in language, in the ubiquitous language, right? These are all terms from the UL. Then you can say in BDD terms, this is my given. So you would make it a BDD test, say, given this happens, and then when I issue this command, then expect this event. So just from a BDD point of view, if you use test language like given, when, then, for example, you can use ubiquitous language in there. You can say given stack has been shelved and cart has been opened. When add stuff to cart, then stuff has been added. When order shopping cart, then shopping cart has been ordered, and so on and so forth. And this could be code, right? This can be event-sourced code in the end. Stack has been shelved can be a class name. This could be a class called stack. Looking at the time, I need to be quick here. 8 minutes left. Stack has been shelved, right? This is your class, and this is basically an event class. And it will have properties, for example, like stack ID and item list. So that's an event that you can serialize, and this is how you would write your given, when, then tests in domain language. Cool question. Good build-up for our big picture event sourcing here. Now, event storming, sorry. We were talking about event storming, right? So this kind of method works in different ways. You can do event storming to understand the big picture of your company, right? To get a big overview and to do a bounded context modeling, basically. You get in all the stakeholders, customers, designers, developers from different teams, and you let them put out all the events, everything that can happen in your domain, not constrained by a certain piece of software you're trying to build, but you really want to understand the whole flow. So most of it will be events, and some stickies are the roles here, right? This is the customer or the cashier or the fulfillment driver or whatever. And there are certain systems involved, be it systems you already have or Gmail or social media, and you just build the whole flow. Starting with chaos, everybody puts out all the events, and then you find duplication, bring the timeline in order, and really make it a visual model that people can understand. Okay, this happens, and then this. If this happens, this cannot happen. And you have some pivotal events here, the ones with the yellow stickies, meaning after shopping cart has been ordered, now your business is in a very different state, and from here, the fulfillment process starts. Great. So you can do a big picture event storming to understand the whole business. And this gives you a good heuristic for bounded context mapping, as well as refining the ubiquitous language in an early stage. It's not a perfect model yet. It is a lot of fuzziness and a lot of duplication or misunderstandings, but it gives you a very fast learning approach to understand the big picture of your business. If you have a big picture and you have your bounded contexts mapped, you can do process model event storming. It has a more fine-grained grammar, and it's about, hey, if you have certain information from your system, there are certain people who can make decisions or actions or send commands, and there are systems that publish certain events, and then you can react to those events. Like you have a policy saying, whenever this happened, do this, or whenever this happened, do this. And this can be managed by a person or by a computer. It doesn't really matter. And using this color grammar, you can refine your domain model. Now it's not about the big picture and the fuzzy understanding. It's about actually how does a process work throughout the whole system. Can span over multiple bounded contexts, but you want to see the shopping cart ordering process. How does it work? Well, I see information. I say put stuff into cart. There's a shopping cart system saying stuff has been added to shopping cart. And blah, blah, blah. At some point, it's like shopping cart has been ordered. Now there's a policy saying whenever shopping cart has been ordered, send confirmation email. Great. You are modeling the whole flow of the system without needing to define class names, table names, anything like that. You just talk about the business, but in a way that is pretty easy to translate into architecture later. And then if you are even finer grained, if you realize this is how we want to build the system, let's actually model this piece of software now that we want to build, the specific classes here for a certain problem. And then you go into software design level event storming, which looks almost the same, but it is a bit more fine-grained. You have queries, commands, aggregates, events, policies, and external system dependencies. And this translates very well with an architecture like CQRS, for example, where you have your command and your queries separated by responsibility. So I, as a person, look into the real world, and here I am this role. I can see information. I can query information from your system. So I query information from your system, and I see, oh, you have this book available. I want to order this book. So now I, as a role, send in a command. I send a command here, order book. And then there's a domain aggregate saying, hey, if this book is still available and the customer is not in debt, book has been ordered. Great. So there's an aggregate, the shopping cart or order system, and the event is book has been ordered. Nice. And this updates our data so I can query, now there's no book available anymore, but this book is in my inventory. Cool. So doing an event storming is pure language driven, pure domain driven. There is no technology decision in there. It's only about how to represent structures from a business point of view, but it translates one-to-one to a software structure that you can implement. Of course, you don't have to do CQRS event sourcing. Somebody asked, could we do ACA actor models? Yes, the aggregates here could also be actors that are already in memory, and the commands go and act on the actors, and then the actors notify about change in state. That also works. It's a little bit less semantic, and I'm more a fan of this one, but no judgment here, right? It always depends on your constraints and situation. There are many architectures that work well. If you are functional driven, you can have functional reactive systems using streams and stream projections. If you're object oriented, you can do actor model or CQRS model using aggregates or not using aggregates. It's totally up to you. Whatever makes you represent your domain better in language and code, that's the way to go. Thank you very much. That is it for today. I would be open to questions now, and I invite everybody to the Miro board. The link should be in the chat anyway already. I'll stop sharing my screen here. Yes, there. Hello, this is my face. So I'm going to pour myself a coffee now after 2 hours and 85 minutes. 1 hour, 85 minutes.
Thanks a lot, Marco. Really amazing. I really appreciated your talk. It was really clear, and I learned also a lot. So really, thank you. A big thank you for your time, for this good presentation. Yeah. So if we have any question, please go on.
You can now also just unmute yourself and speak. I'm happy to answer verbal questions as well.
Personally, I have a question about the link that you talked at the beginning of your talk about Agile and DDD. Could you explain a little bit more about that?
So how Agile and domain-driven design work together,
Yeah,
right?
that's it.
DDD and Agile per se are very different things. Domain-driven design is about modeling and understanding. It's about strategical planning of your models, of how to separate your solutions into smaller models that serve the problem space better, or the purpose space, and how to implement in a linguistic way. And of course, that's not a final definition, but this is roughly what DDD is about. Agile is about feedback loops and doing project management in a way that is leaner or with better communication, higher psychological safety, and iterating as fast as possible to steer in the right direction and getting away from all these hindrances like contracts and things we said in the past and stuff like that. But these approaches go hand in hand, so they are not mutually exclusive. They are not the same, but even in learning, right? Learning doesn't happen up front. You can't just do all the learning and then do the building. You can learn a lot from an upfront modeling, and you need to do big picture event storming or something like that in the beginning of a project. Whatever method you use, you need to get an understanding of what you're actually trying to do here and why you're trying to do it. But in the beginning, you have the least amount of information, even if you get a lot from good modeling. And then you build some part of the solution and you iterate and you refine language. And 2 months down the line, you learned more and the business learned what you're actually trying to build, and stuff changed. Your understanding changes. So you need to iterate your model. You can't just build the model that you've learned 6 months ago. You need to change your model when you learn more. And there is already a heuristic in DDD from Eric Evans' book called Refactoring to Deeper Insight, right? You change your model when you learn something. But with Agile, you can make this even into a ritual. So what I do is whenever I start a new project or whenever I start a new sprint or however you separate your Agile methods, I start with a modeling session. I start with an event storming of what do we want to build this sprint? Even if we already know what to build, let's just take 2 hours of our time collectively and build a model together of what we actually think we need to build here. And every time, really every time, we learn something new. We learn that we had a misunderstanding, or that, yeah, it was clear to one person, but the others were like, holy moly, that's not what I thought. Oh my God, yeah. And even if worst case scenario, you just learn that everybody had a perfect synchronous understanding already, then now you have the guarantee for just 2 hours of investment. So yeah, iterating your modeling and iterate over your mental models and the separation of your company from big picture and bounded context to how you separate your teams down to what are the class names and the method names, how do we structure our code. You always learn on the go, right? You always keep learning. So another quote from Alberto here is software development is a learning process and working software is just a side effect. And this is more true than anything else. You never deliver software. That's not what you do. You deliver business solutions. You help people with their problems. You either enable new abilities or you help get rid of old problems by automating cognition, for example. And whatever you deliver is the closest understanding you had at that point in time. But the real value you deliver is learning about the business and finding better ways to represent contexts so that you can build better solutions all the time. So this is where Agile and DDD is, for me, it became like a uniform thing.
Okay.
I do not really separate there. It's we need to build models. We need to figure out what's our core business here. And what our core business is changes over time. So we need to have rituals where we iterate and try to rethink, is this still our core? How did our relationships change? How does this affect our system? And yeah, basically, I started with Scrum, then did some Kanban, at some point ditched both concepts, and we built our own kind of reflective loops because they are faster. Whatever you do, you can build the modeling and learning in your iterative processes, and you need to do that if you want to build good domain models. So it goes like this. Looking at the DDD whirlpool, that is an already iterative process, right?
Yeah. So it's not really a prerequisite to having an agile team before starting DDD. Okay.
No. They can be completely exclusive.
Yeah,
you
okay.
can do agile without DDD. You can do DDD without any agile. That's totally fine and works well. But they both work well together. If you do both, you gain more benefit on both fronts. You learn better and you build better software in faster iterations, and you are always value-driven and domain-driven. So all this is just blowing into the same horn the whole time.
Thank you.
You're welcome.
People from YouTube are also thanking you. I think your presentation was really great. It was so simple and easy. Can you please share your the link of your slides again?
Yeah, let me
Thank you.
I'll
So I
post it here in the chat. Please relay it to the YouTubes.
thank you.
And I'll make sure that the board is actually open for the public. Yeah, the public can see and comment, but not edit. So enjoy. If you have any additional questions, not now, but later, you can comment on this board if you have a Miro account. It's for free, so make a free account. If I see any comments in the coming few days, I'm going to answer those. So if you have additional questions, feel free to ask. End of sentence.
And don't hesitate to give feedback to Marco so he can improve his presentation.
Yeah, please. Okay, cool. So if there's no more questions so far, I'm going to make myself a pizza now, and I wish you a wonderful evening. And I hope to see you at one of the virtual DDD meetups in the future.
Thank you again, Marco. Thanks for your time. It was a pleasure. Have a good night and a good pizza.
Bye.
Bye-bye. Thank you. Thank you, participants.